Now with this exponential graph, we don't have a scale here. I didn't say how long this was. What we want to do is we want to label the axis for the problem you saw earlier about $1,000, which increases by 10% every year. Now you recall that if you did this correctly, and I think everybody from whom I've gotten the homework has, if you're the one student who's been out for the last couple of days due to some very good reasons, that might not be the case, but I expect that you got that also. So if this doubles by the 8th year, well, you recall that the amount did double. We reached $2,000 by the 8th year. Okay, we didn't reach it by the 7th year, but by the 8th year we were over $2,000. And some students who've had Algebra 2 and know a little bit about solving logarithmic equations were able to actually find the doubling time, which I believe is around 7.3 years. So let's assume that that's the case. Okay, so how are you going to relabel this graph? You got to label the y-axis so it shows the dollars. You got to label the x-axis so it shows the years. So you should stop and think about that and give that a little bit of thought. It's worth thinking about and trying to get without watching what I do. Okay, but assuming you've done that, there are many ways you could do this. So the way we did it in class, and this is just, I had everybody standing there and people took turns doing things at the board, and actually we had a volunteer come up and say, okay, I think I can do some of this. In fact, I drew a line here as it goes through the axis where the graph does. Actually, I kind of screwed that up. It's a little bit high, but it's supposed to go through the axis right where it meets the curve. So, and on this line, y equals 1,000. Now I'm going to label the y-axis. I'm going to say y, and that's going to be in dollars. And this axis is going to be the x-axis in units of years. So we have y equals $1,000 on this line. Now, how are you going to label the graph? Okay, well, what was done by a student in class? Okay, well, let's see. There's y equals 1,000. If y is going to double, it's going to become 2,000. So I take whatever this is, and I double it. I get up to here, and here's my line. For y equals 2,000. Okay. Now we know that the amount doubles, so that at the point where the graph intersects the line for y equals 2,000, we know that the amount will have, by that point, doubled. Okay, so right here is the doubling time from here to here. So that there's the doubling time, because between here, which is at x equals 0, and here, y value has doubled. So this arrow indicates the doubling time. So that's kind of good. Now, the other thing, of course, and the way I would have kind of expected people to answer the question, although this is every bit as good as that, is, well, let's see, the doubling time is 7.3 years, and y doubles when x changes by this amount. So that this ought to be the doubling time. The length of this arrow ought to be the doubling time. Now, when we did this, well, let's see how long. There's that arrow. Now, I'll try to keep my fingers the same. And right there's our doubling time. And it looks like we kind of almost nailed it. And in class, we really did nail it. We got it very close. And there was no premonition, no intent, no attempt to try to make this come out as long as this. That's just the way it worked. Now, there's a little discrepancy in this graph because this doubling time arrow is a little bit longer than most of the ones I used. Okay? Like this one actually is a little short. Although, yeah. And you see that these marks don't quite line up exactly as you would expect, but for a graph where we're doing it by hand and doing it by estimates, that's actually quite excellent. This is a good approximation. The one that people themselves did in class is even better. So anyhow, here's our doubling time. So let's just say then, well, another doubling time would be here, and another doubling time would take us to here, and another doubling time would take us to here. So that this point on the axis, now things are getting a little crowded, but X in years would be 7.3 at this point. And then this would be two doubling times. If you double 17.3, you get 14.6. And if we add another 7.3 years onto 14.6, we get 21.9. So I'm going to have to put that kind of down here. So the labeling's getting a little sloppy. And then this one would be 29.2 if I've done my arithmetic correctly. So these green numbers that aren't really, don't really even look like labels because they're scattered all over the place, would be the numbers that we'd use to label the graph. And this would give us a good graph of how the money grows. So if we wanted to find when the value of the money was $6,000, we go here to here to here. It looks like about here. We come over here. We come down here. And we say, well, if this is 14.6 and this is 21.9, that looks like it's a little less than a year. That's about 20. In about 20 years, we ought to be up to $6,000. Now, you wouldn't really use a graph to do that, but you can use a graph to visualize how that works and to make estimates of how long it'll be. And there are techniques that you probably haven't gotten to in your math classes that allow you to actually put a formula on this function for these numbers and solve the equation. When does that function equal 6,000? Something we're not going to get into in this course, but you will see this sort of thing. And when you do, you'll have a much bigger context for what an exponential function is and a much better ability to look at and read a graph than you would otherwise have, which is one of the goals of this course. This is something you're not going to see except in this course. It's something you're very unlikely to see.